Welcome back, everybody. In our next section, we're going to spend some more time doing detailed verifications of segment routing with OSPF. And I have briefly talked about some of those commands. They're mainly going to be a subcommand of show IP OSPF segment routing. So let's go ahead and take a look back at the topology. And we have the three regular iOS or the iOS XE nodes on the bottom, router 1, 2, and 3. And if we go to router 1, let's take a look at the actually full screen. Show IP OSPF segment routing. Okay, we'll see there's a number of options after that, but we can just say show IP OSPF segment routing. And what this mainly is going to tell us first off is whether segment routing is globally enabled. So two things that need to be set. One is that the global state is enabled, and that the other is that you have it enabled for the particular area. Okay, notice the segment routing global block, the sRGB, is the default value, like I had mentioned, 16,000 to 23,999. And then in here somewhere we should see our what our index value is for the node segment ID. Okay, so if we show IP OSPF segment routing, what are the other options? We have conflicts. Okay, conflicts would show us if somebody else has the same node SID as I do. So we configured router 1 with index number 1, which means it's 16,001. So for example, if you were troubleshooting that, let's say we went to router 3 and we show run pipe section segment. Okay, if we said that the index was 1, okay, the same as what router 1 was using, then back on router 1 we look at the show IP OSPF segment routing conflicts. Okay, it's going to tell us in a minute here who is causing the conflict. So if we look at router 3, show IP OSPF segment routing conflicts, it says the advertising router is 1111. So I'm not 100% sure why the output is different on both sides, or on one side versus the other, but at least we can tell from router 3's point of view, it configured its own loopback 3333, and it says it's being advertised by 1111. This just means it's an overlapping value. Okay, so let's go back to the original config, which was index 3. Index 3. And on router 1, let's show IP OSPF segment routing. Okay, we have the local prefix. This would be our mapping. So our segment ID is 1 for our loopback, which is 1111/32. Okay, again, you can technically map other prefixes. I'm not 100% sure why you would need to do this in a real design, because the tunnel is always going towards your loopback. Well, actually, no. There is one case I can think of if you have two loopbacks. So maybe one loopback is used for certain customers, and then another one you have traffic engineering steered to, loopback 1 versus loopback 0. You could, in that case, advertise multiple segments, but the segment itself is arbitrary. You can configure whatever you want. So if we show IP route connected, let's say we were to advertise a segment ID for 10120/24. So if we show run pipe segment routing, show run pipe section segment routing. So we're going to go under segment routing, go under the connected prefix SID map, and then we're going to say our prefix is 10120/24. Okay, we'll give it an index of 24. Okay, if we look at from the other routers now, show MPLS forwarding table, we should see 16024 maps to 10.1.2.0/24. So if we now do a trace to 10.1.2.1, it's using that label. Okay, so from router 3, it's going to 13. 13 it goes to 2, 2 goes to 1. Now, I'm not 100% sure why that link was not labeled. Oh, actually I do know, because 2 is connected to that segment as well. Okay, so I advertised this segment here with segment ID 16024. When router 2 advertises this to XR3, it is the penultimate hop. So it's saying I'm connected to it, so I'm going to advertise implicit null for that. This is another reason why you wouldn't advertise your transit links. You would always want to steer the traffic towards the loopback. This fixes that problem where the PHP process is happening one hop too soon in the core transport. Okay, but on router, actually any of these, let's say look at the show, actually back to router 1, because we want to see the local ones. Show IP OSPF segment routing, show IP OSPF segment routing, and then the local prefixes. Okay, so we're advertising 2 prefixes. Those are the segment IDs. If we said, let's look at the entire database, okay, SID database. So this we can see what are the local prefixes, and then what are the ones that we are learning. Okay, type is intra-area route. Okay, technically inter-area traffic engineering is supported. Inter-domain traffic engineering is also supported with segment routing because these values are global. Last one, there was a question about how do we check the actual opaque area or the opaque LSA. So let's look at just the show IP OSPF database. This shows that we have all these type 10s for area 0. This is where it's encoding the label number effectively. Okay, so advertising router 1111, if we said show IP OSPF opaque, or show IP OSPF database for the opaque area, and 1111 is the router ID. Let's see, opaque area. Why did that not come up? For the, no, the advertising router 1111. Okay, segment routing algorithm is using IGB based, so it means use dynamic routing. Let's see, and I'm not 100% sure how to decode this because it shows us the prefix there, or there it is, there's the segment ID. Okay, this is the index. So we saw with the just show IP OSPF segment routing that it showed us what the segment routing global block was. We advertised this to somebody else. They look at their global block. They add the segment ID as the index, 16,000 plus 1. That ends up to be router 1, 16,001. Okay, unfortunately on iOS XR, there's not really as many verifications. If we show segment routing, okay, there's only show segment routing mapping server. And this might be a version issue, maybe in 6.5 or something that's later than this. If we look at show version, this is 6.1.3. So your mileage may vary depending on what version you're running when when you watch this video or when you try it out. But we could look at the show OSPF database, and then likewise we see the opaque link area, link states. So we could say the same thing, show IP or show OSPF database opaque area, but unfortunately, this is kind of hard to decode versus the other output that you see in regular iOS. But we could know from this, let's say like for router 12, what is the index it's advertising? It should just be index 12.